All right, to be continued. So let's look at our example. We had two balls, so two M's, right? And they were in collision at some velocity v, right? We tried to make the following happen. 1m come out of collision at what speed? 2v. Does that work? Does the math work out there? Can you rearrange those multiplied variables any way you want? You betcha. Now let's do the kinetic energy version of this. Kinetic energy is 1/2 times the mass, 2m's, right? Times v squared. That will have to equal 1/2 times 1m times 2v quantity squared. Does that work?
No, the 2v would be significantly more than just v squared.
That is correct. That will not. So the 1/2 will cancel and the m's will cancel. Oh no, this will be 2v squared and this will be 4v squared. Is there any number that I can put in for v that will make that true besides 0?
Nope.
0 is the only one that works there. So sitting right now, sitting still, that works, but that's not helpful at all. So the only time that these perfectly elastic collisions really do work is in the subatomic world. And I will tell you, we will never use this big old messy equation. However, when you have a perfectly elastic collision, momentum is conserved, and there's another equation that also works. It is as follows. If you take the difference in the two velocities before the collision and swap the order, that will also work. So V1 initial minus V2 final will equal V2, oh dang it, I always do this wrong. V2 final minus V, good Lord, let me rewrite this so that you can actually understand it. Here we go. V1 minus V2 initially will equal V2 final minus V1. And I think we're just going to do an example, and then it'll become clear. This is a fairly simple equation, and it only works in perfectly elastic collisions, which pretty much only exist in the subatomic world. So let's do an example. All right. Let's say I have a 2 kilogram mass moving at 5 meters per second to the right. It strikes a 1 kilogram mass perfectly elastically that's moving at 1 meter per second to the left. Is momentum a vector?
Yes.
Yes. So make one of those directions positive and one negative.
5 meters per second.
All right. Thomas decrees. The 5 is positive and the 1 is negative. They whack into each other, and then later they both move off to the right. Now, how would I know they would move off to the right? Right, I drew it that way? Yes. Oh, there's the other one.
Because of the equation.
Well, how much rightward momentum do I have here?
5 meters per second.
Momentum. Mass and velocity, mass and velocity, mass and velocity. How much momentum? 10. How much momentum here?
2, negative 2.
1 times 1,
Negative 1.
negative 1. So 10 or negative 1, which one wins? 10. So I'm going to make these both move to the right. Okay? But now I don't know either velocity because I have two equations that I can use. I can use momentum, which you already said this was 10, so 2 times 5, plus, what's the momentum here? Negative 1. 1 times negative 1. The equal sign goes where the collision occurs. And then this is going to be 2 times V1 plus 1 times V2. The other equation that's also true is the relative velocity equation, which is the difference between these two velocities is equal to, flip them, the opposite of the difference between these two velocities. Hum and whistle at the same time. Do it. Oh, I'm sorry. It's kind of fun, isn't it? That's not very far trip for Wes to get upset. So. All right, so let's do the math here. What's 2 times 5 minus 1? 9. And then that's 2v1 plus v2. So that simplifies, but we still have 2 unknowns. Now let's use the relative velocity equation. The relative velocity equation says v1 minus v2 equals v2 minus v1. You just switch the order. Got it? So v1 minus v2 equals v2 minus v1. What's this side of the equation? 6. Now you have 2 simple equations. Can you do some fancy substituting and solve? I think so. Let's solve this for, let's solve this one for v2. What does v2 equal? Yep, 6 plus v1. And then I'm going to substitute that right here. And then this equation will become 9 equals 2v1 plus 6 plus v1. Can you solve that green equation in your head? Yeah, 1. v1 equals 1. 2 times 1 is 2. 2 plus 6 is 8. Plus 1 more is 9. v1 equals 1. 1 meter per second. And what does v2 equal? Look at this. 6 plus 1? 6 plus 1? v2 equals 7 meters per second. Those are the answers.
So why do Eastern Europeans and like Russians love physics so much?
I don't know that I think it's just a stereotype.
That's what I'm saying, like, 'cause, like you've had Eastern European or Russian, like,
yeah.
teacher and all these people have.
And Einstein was from Germany. So. Yeah. Okay. So these are perfectly elastic collisions. Got it? That's the only special exception. All the rest of them, we're just going to use momentum. So in honor of the stereotype, we will practice so that you become what? Fit?
Perfect.
Physics champion! Yes, let's go. All right, work with your table partners. Oh, by the way, if you would like to derive for extra credit, this, oh, you can't see it all. This equation, V1 minus V2 equals V2 final minus V1 final. From these two, if you use some substitution and do the following, look at all the algebra, canceling. Oh, you do eventually get that, so feel free for extra credit. Sure. No. I did record it. Oh, that would suck all the joy for you, wouldn't it?
No.
Yeah, Peter Chen did it in like 5 minutes. 5 minutes while I was lecturing.
Wait, can you edit these videos?
Can I edit? You mean can I go back and take that out? Sure.
Don't do it. Don't give that either.
All right. So derive this from these for extra credit. Okay, here's your practice.
Staff and students, sorry for the interruption. The senior meeting is concluding now in the Student Center. Teachers, you can expect seniors to be back in class here within a couple minutes. Thank you.
Okay, here we go. What happened? Oh, there we go. So I have a 2 kilogram mass. These are all in kilograms, moving at 4 meters per second. Got it? 2 kilograms. It collides with a 3 kilogram mass, moving to the left at 2 meters per second. Since they move in opposite directions, what should you do? Yep, make one. Which one do you want positive? And the 2 is negative. Okay. They collide elastically, but not perfectly elastically. So elastic means they do what? Do or do not stick together. They do not stick together. So I'm going to make the 2 go backwards at negative 2 meters per second. And the 3 will go forward at some unknown velocity v. Find v. Now remember, you can just set this up, mass, velocity, and put your equal sign right here. Go.